Question number 65. How does the dynamic resistance of the diode vary with the temperature? Already a question was asked on dynamic and static resistance of the diode in the previous questions. I did not remember the number. This question is again a repeat from the dynamic resistance of the diode. Very simple question. Hardly takes 30 seconds for you to answer if you know the concepts of AC resistance or dynamic resistance, or if you have listened to my video. Question number I'll tell you. Question number 20. Yeah. Question number 20, if you can listen to my question number 20, you can answer this question within 10 seconds. Fine. How does dynamic resistance of the diode vary with the temperature? So dynamic resistance is also called AC resistance. I discussed in question number 20. So dynamic resistance is denoted with a letter small r, AC resistance will call. So this formula is given by neta Vt by IDC. Neta Vt by IDC. Neta is 1 for germanium and it is 2 for silicon. It is 2 for silicon only for large currents. For small currents again it's 1. So I don't want to discuss about this right now. Just remember 1 for germanium, 2 for silicon. Later we'll discuss. So we don't have any significance with neta right now. So RAC is proportional to Vt divided by IDC. So what is Vt? Neta means it's a constant. Okay, you agreed. What is Vt? Vt is nothing but Kt by Q. It's nothing but voltage temperature. Kt by Q. K is the Boltzmann constant. T is the temperature in Kelvin. So Q is the charge of electron, 1.6 into 10 power minus 19. So if you substitute K and Q, these are constants, you're going to get 1 by 11,600. So just remember that Vt is nothing but T by 11,600. Everybody will remember this expression, I guess. So Vt is nothing but T by 11,600 volts. Okay, so try to remember this expression. So you know what is neta, you know what is Vt. IDC is nothing but the current across the diode, IDC. So what I mean to say is RAC is directly proportional to Vt. From this expression, from first equation you can say that RAC is directly proportional to Vt. From second equation you can say that Vt is proportional to T. You can see it's directly proportional to T, or you can see here T by constant. So Vt is proportional to T. So from 1 and 2, what can you conclude? RAC, how can you relate resistance with temperature? So RAC is proportional to Vt. Vt is proportional to T. If temperature increases, Vt increases. If Vt increases, RAC increases. So what I mean to say is, from 1 and 2, what can you conclude is RAC is directly proportional to T. So in this way, you can say that dynamic resistance of the diode is directly proportional to the temperature. So option A is the right choice. So this is a very simple question. If you have listened to my question number 20, you can answer the hardly in 10 to 30 seconds. So this is the end of this question. If you have any queries, post them in the comment box and subscribe the channel for getting more updates.